Hello everyone. Today we are going to discuss a question related to the concept of neural network and gradient calculation. Okay, so this particular question is taken from this assignment 5 of this course given in this course Introduction to Machine Learning by NPTEL. Okay, so the question let us see what is the question is regarding. So consider a two-layered neural network. Okay, y output is y, which is obtained by applying the sigma. Okay, the sigma generally is an activation function, and that activation function is called the sigmoid activation function. This y is obtained by applying this sigma on WB. Okay, so from this notation W, it is nothing but some weight values again multiplied by with another applied sigma function on another set of weight values and the x, which is the input parameters. Okay, so if we try to visualize this, we can consider that we are having a neural network. Okay, and it is a two-layered neural network we are saying. So we are having the x input layer, then we are having something called the hidden layer. Okay, in the next sentence you can see h equal to sigma applied on the weight matrix W superscript A multiplied by x. So this x is my input nodes, right? And this h, which is obtained by multiplying the weight parameters WA with x, this will represent the hidden layer. Okay, so as you can see, all these current layer, that is the hidden layer neurons, they are connected through some weight parameters with the input layer. Okay, with the input layer nodes. Okay, now this hidden layer we are denoting as h, and this is obtained from the weight matrix W superscript A, which is multiplied with x. Okay, then what is the final value? That final value or the output layer, okay, which is denoted as y. These again, these y neuron values are obtained by what? By applying some sigmoid function parameter values, some sigmoid parameter values on what? On this portion. This just now we have seen, this is nothing but our h, the hidden layer, correct? So these y values are obtained by multiplying a weight matrix called W superscript B with the hidden layer values, right? The hidden layer feature values. So this WA and WB, these are some arbitrary weight parameters. Okay, now which of the following statements is a true and false? It is asking. Then another notation is given. Okay, that is nothing but the gradient. Okay, this notation is the meaning is that we are finding gradient of some function f, but with respect to this variable called c. So this is gradient of f with respect to c, correct? Now here if we see the options, we are finding some gradient parameter values. Okay, gradient with respect to some other parameters, right? Gradient of some output value with respect to some parameters, and we are trying to find out the dependency of that gradient calculation on these variables. Okay, now going forward, before going forward with the options, let us have some general understanding of what is happening in this neural network. So in this neural network we are having this x, these are the input nodes, which if we go from left hand side to right hand side, which is also known as forward propagation in a neural network. Okay, when we apply this forward propagation, what we do, we multiply x input values with some weight parameter value, and we obtain the hidden layer values h. Okay, so basically these hidden layer values are dependent on w as well as the x value. If we vary either w or x, my h parameter value will vary. Then if we go forward to obtain these y values, the neurons that we got in this y or output layer, those are again dependent on the wb, these weight matrix again, which is multiplied with h, right? So these are directly dependent on wb and h, and indirectly again dependent on w, a and x also. Why? Because this h value that we have obtained, that is nothing but multiplication of w, a and x. So the y is directly dependent on w, b and h, and indirectly or in return dependent on w, a and x. Now this is the case during forward propagation. Then what we do, we do some error calculation here in this neural network. Error calculation I will do, and if the error is high, we try to minimize that error by doing another operation called back propagation. Okay, back propagation. So in case of back propagation, we go from the right hand side to the left hand side, from the output layer towards the input layer. And while going, so what we do, we update these weight parameters. Okay, update these weight parameters. Now while doing this back propagation, we do one calculation called gradient. Okay, we do this calculation which is known as gradient, and gradient calculation is mathematically we can represent with the help of derivatives. Okay, standard derivative or partial derivatives. Okay, because here we are having multiple independent variables, so we generally follow partial derivatives. Correct? Okay, so this gradient notation, if we see, that means we need to do the derivatives with respect to some variable. Okay, so in case of back propagation algorithm, when we implement it, we implement inside one algorithm called gradient descent. Okay, this gradient descent is an optimization algorithm, and we apply different variations of gradient descent. Okay, and in this gradient descent algorithm, we calculate gradient of some function with respect to some other variable. Now as we can see, while doing this gradient calculation, if I do the gradient calculation, okay, we are dependent in the reverse way. While doing the forward propagation, in this flow, we suppose h is dependent on wa and x, then y is dependent on wb and h and wa and x. But in case of back propagation, when we go from right hand side to the left hand side, all these dependencies are also reversed. Okay, when we do some updation on wb, we are dependent on the y values. When we do some updation on this wa parameter, we are dependent on the h parameter, or in turn the wb parameters. Okay, so these dependencies are also reversed in case of back propagation. Okay, so having this general understanding of this neural network, where we are having input parameter, input values, the weight parameter values, the output values, the hidden layer representation, we will see what is asked in these different options. Okay, so the first option, if we try to decode the first option, it is asking what? It is asking it is taking gradient of y with respect to h. So gradient of y with respect to h. So that is what? That is, we will take derivative with respect to h of this y parameter value, correct? And what is this function of what is the formula of y, which is given here, right? The formula of y has what? In the denominator it is having h, right? And in the numerator some sigma function only we apply, but we apply it on wb multiplied by wh on this calculation, right? This part wa multiplied by x, this is nothing but my h only. Correct? So that's why this particular calculation, okay, it will since we are taking the derivative with respect to h, and my numerator term is also having h, correct? So this particular derivative will yield some term, some little complicated calculation, but that calculation will always have this particular parameter called wb. Okay, so here using this particular symbol, I just want to mean that when I am taking this derivative with respect to h, whatever value we get, that value will have this wb. Okay, this is not directly the answer, but the answer will have some values which will include also this wb. Okay, so that's why we can say that this derivative is actually dependent on wb, correct? But the option is asking whether it will depend on wa. Does it depend on wa? No, my final term will not have wa, because denominator is having h, which will have the wa, but numerator is also having a. So while doing the derivation, that term will not be there in the final answer. Okay, so that's why it is a false option. The option is not true. Okay, then the second option it is asking gradient we are taking now this time of y, but with respect to wa, correct? So here this y, we have to see how y we get. Y we get from what? wa of y, right? So this y we will get from what? Some sigma, some function only on wb, then multiplied by h, right? So we can here directly we can see that this h is what? This h is wa multiplied by x, and we are taking this derivative with respect to wa. So finally my final term should have wb and also maybe x, my final term. So directly we can say that, or we can also apply something called chain rule. Okay, chain rule on the derivative. Okay, again this is a very popular rule on which is apply on partial derivatives. So this further we can write as ddh, because my term, this term is directly having what? Directly having wb and h, right? So I can apply chain rule for simplification and write something like this, correct? So it will again give what? It will again give me this denominator numerator both are having h. So those that final, this first part will something will have something like wb, and the second part you see again h is wa multiplied by x, right? And we are taking the derivative with respect to wa, so the second part will have x, correct? like second part will have some calculation involving x, because it's sigma, right? It's sigma. So in the final term we can see that we are having x as well as the wb. This is not equal, but the term is the term, final term will have variables this wb and x. Okay, so the question it is asking whether the second gradient, okay, this second gradient calculation depends on wb or not. Yes, the second calculation will depend on wb, because my final calculation is having wb. If I change the values of wb, my this gradient calculation will also change, right? So second option, that is true. Second option is true. Okay, so here let me write here true. The first option was false. Okay, now again we go forward to do the to calculate the third option. Third option is WAH. Okay, so the option C, we are taking gradient of what? We are taking gradient of H, but with respect to WA. So it will give me what? DDWA of H is what? WA multiplied by X, correct? So the new denominator and numerator both are having WA, so final calculation will have X. Okay, final calculation will have X. So this particular, now the question, if we go back, it is asking whether this third gradient is dependent on WB, whether it depends on WB. But you can see that the result is not having any term including WB. Okay, so this is again false. Then what about the option D? Okay, option D is gradient of y with respect to WB. So option D is, we are calculating gradient of y with respect to WB. Yes, with respect to WB. So again this calculation, if we see, we have to calculate derivative with respect to WB, but for y. Y, again, what is the formula of y? Okay, y is it will have a sigma term, but WB multiplied by H, correct? Which is again it will have what? It will have the term, this final calculation will have the term H, not exactly equal to H, but the final term, again it is a little complicated calculation because it is sigma. So the final calculation will have other terms, as well as this H term will definitely be there. Okay, now what is the option? What is the option? The option is asking whether this depends on WA. Now again this H, how we get the H? H is nothing but, if we apply the sigmoid function on WA multiplied by X, then we definitely get H, right? So this final term will definitely have the term WA. That's why this particular gradient calculation, whether it will depend on WA, yes, it will depend. So this will be again true, correct? So I hope that is clear here. That's why the correct options are option B and D. Okay, the rest of the options A and C, those are false. Now here when we take this, just for additional information I am informing that here whenever we take gradient like derivative of the sigmoid function, okay, if we take derivative of this sigmoid function, this function, like it will give me like, if this particular function, this sigmoid is what? It will be ddx of, actually it is 1 plus the sigmoid function is 1 divided by 1 plus e to the power minus x. Okay, when I write sigma on x, so that the meaning, the inside function is 1 by 1 plus e to the power minus x. So this final term, okay, it will give me a calculation something like this: sigma x multiplied by 1 minus sigma of x. Okay, there is again how we end up with this function. There is if we step by step apply this particular derivative on the exponentiation term, then we end up here. Okay, so that's why I am telling, whenever this sigma we are applying all this derivative, okay, but this is not applied on the straightforward this calculation. It is again applied on the sigmoid function. So again this will yield a complicated term, but that term will have this particular h or wa. Okay, so I hope it's clear. Okay, thank you.